Hello folks, welcome to the meetup. Thanks for coming, really appreciate it. Very excited to see so many faces join here. We have people from two meetups over here right now. There is East Bay Cloud Native Meetup, which is the one we just started. I organized it, and this is our first meetup as part of that. And there are some folks from another meetup called Docker Containers, Cloud Foundry, and PaaS. And welcome to folks coming from both the meetups. A little bit of background why I started this. By the way, my name is Sudhanshu Garg, and I work here at Oracle in Cloud Native space. And I was finding any meetups over here that I could go to just enhance my knowledge and share what I'm doing and also learn from what others are doing. And I spent like many months trying to figure out there is a meetup over here that I could go to. It always ended up being going to either San Francisco or South Bay, which were very far. Sorry guys who commute that far or who are coming from that far, but I found it really painful. So I thought maybe I can start one and see if there is enough interest, then we can have this on an ongoing basis. Looking at the people who are coming here today, I'm thinking we could try to have it once every month, like every third Thursday is what I'm thinking. And finding great speakers is going to be one of the challenges, but I would like to see people from this group come up as speakers and share your experiences. The idea is that we all collectively learn what's going on in the cloud native space. It's a huge space and it's pretty hot. I mean, there's so many technologies, Docker, Kubernetes, and then serverless computing, microservices. So we are going to be talking about all those things going forward so that we can learn how to develop a modern application using these technologies. Some logistics, if there is an emergency, then we will all be exiting from that door. And we'll go to the parking lot from there. That's the easiest exit. And we are on the first floor, so we don't have to worry about taking stairs. For the restrooms, you would go out from this door, and you'll turn right, and you will see a sign for restrooms over there. Then for the Wi-Fi access, you can connect to the Clear Guest SSID, guest username, and the password over there. I think that's about it on the logistics side. For the PPT that we will be having today and the recording, we will post it online. So feel free to take pictures if you want to, but the presentation will be shared later on, so you don't have to if you don't want to take it. Without further ado, I would like to introduce our speaker for tonight, Dave Nielsen. He's the head of ecosystem programs in Redis Labs, and he has extensive experience in cloud native space. He has been running cloud camps for many years around the world, and he has before Redis Labs, he was promoting the Intel's BigTL container project, and he was also a key player in getting the PayPal's web API published online. So we are really excited to have him. He's driven all the way from Mountain View, which is a long commute. So let's welcome Dave.
Let's do the Mike song and dance here.
Yeah, that's always a challenge.
Okay, and what
Here it is right here. Yeah.
just like that. Okay, and oh, just got that one right there. Thank you. And this one. That's what got me last time. It's that one. Should just take a second here. Okay. So thank you, Sudhanshu, for inviting me and also inviting another meetup group that I helped organize. In fact, for those of you who are here from the other meetup group, it's kind of a funny story because we wanted to organize a meetup actually like this a while ago, and I was doing some consulting for a company called Altoros, and they do Cloud Foundry, and they're just thinking about Kubernetes, and they like the overall category of PaaS, and Docker was hot, so like, what should we call the meetup group? So I was like, well, they can decide, so it's called like the Cloud Foundry Kubernetes PaaS Docker meetup group. So it was pretty funny, but they were all down in the South Bay, so yeah, it was kind of hard to come up here. So while the meetup group met every so often, and I came up every once so often, it was just too hard. So that group has a pretty decent size to it, but not a lot of activity. So it's great to have this meetup group with a local organizer who can help make it work. So a couple things I'd like to first share. Yeah, I did help PayPal get its first APIs off the ground. That was a long time ago. Kind of forgot about that, but you can see the little gray whiskers here. Yeah, so it was a very interesting time, and I like to bring some of my experience to these talks. I'm not a deep technologist. I'm pretty mellow on the technology, but I have a lot of experience working with different ecosystems, and I can predict a lot of stuff. You know, when you've been around for a while, you see the arches, and you can start to predict where things are going based on the trends. A good example of that was I was doing e-commerce consulting in the late 90s, and of course I'm doing all these integrations, and I remember there was always these arguments over, well, you should just use Java, or of course the Microsoft folks would be like, use Microsoft technologies, which nobody did, but there was always these arguments, or handcraft your comma or your name value pairs and all this kind of stuff to exchange information. And you just see over time, you're like, this is just a nightmare. And so when Microsoft and IBM and a couple other folks got together to propose web services, it was obvious that something like that needed to happen. And so I started a web API user group in 2000. And that group was about 3 years before the next web API user group in the world. We were way early. But I ran that group for about 2 years, and that's when PayPal was getting ready to launch its web API, which was one of the very first. And so they hired me to be the evangelist really for that API. And so that's how I got my start really in the heavy tech. Before that, I was really just doing web application development. And as a part of evangelizing those APIs, it was actually more of an effort of evangelizing APIs in general, because back then, you really couldn't convince people that web APIs were a good idea. Sounds weird, huh? Because you'd say, why don't you use web APIs? And they'd be like, why on earth would I want to add somebody else's server's downtime to my server's downtime? It was a bad idea, apparently. But when money's on the line, of course, I need to make a payment, or I need somebody to process somebody's credit card, of course they'll do that. And that was one of the groundbreaking APIs that really got people to think about, okay, I'm gonna go ahead and send data across the wire and get something back, and my application would rely on that. And then in about 2006 is when APIs finally hit, and that was when the mashups started happening, and that's when you saw Google Maps, I forget the guy's name, but he kind of reverse engineered it before they actually had an API. And you start seeing applications that were very simple web applications with maps on them, and they put like rentals or houses or whatever on there. And that's about the time you really saw the need for some easier way of doing web hosting, and that's when the cloud started to kick in. There were all these mashups, all these simple applications, and it couldn't grow. That whole ecosystem could not grow unless there was an easier way to set up a server and get something going and shut it down when your mashup is done. So there was a group called Mashup Camp that organized unconferences around the idea of mashups. Anybody hear of an unconference? A few of you? Okay. So the idea of the unconference is you show up to a conference and there's no predetermined speakers. And you sit in a room like this and you go, okay, what do you guys want to talk about? And people raise their hands and they come up and propose topics. And you then create sort of discussions on the fly in different perhaps in different rooms if there's enough people. And I thought, wow, this is really a great idea. Why don't we do that around this new thing called cloud computing? So I created with a few other folks something called Cloud Camp. I thought, oh, we'll do one of these just like the mashup camps. We'll do like one every 6 months. You know, we'll talk about is this idea of having virtual machines in the cloud that could disappear at any moment, is that a good idea? You know, and people are like, this is a terrible idea. It'll never catch on. It's a fad. You know, all the traditional IT people are like, it's just virtual machines. You know, what's the big deal? Anyway, so we organized this, and the darn thing went nuts because we organized the event and then we published it and said, hey, you know, if anybody else wants to organize their own, they can use our brand. We'll help you do it. We'll help you raise sponsorship money, all that kind of stuff. Put a list of like how to organize an unconference on the website, and all of a sudden people were coming out of every continent, every major tech city. And instead of doing one every 6 months, we did 10 in the first 6 months. We did 30 in the next 6 months after that. At the peak, we did 92 conferences in 1 year, and it was all volunteer, no major sponsors. It was all like kumbaya. This cloud is gonna save the world. So anyway, the point is that in those cloud camps, it was almost all discussion because you don't have presentations. People don't have presentations. They don't even know they're going to present. They're just going to get up there and like, hey, what ideas are interesting? So we had 375 of these cloud camps over all that time, and I went to about half of them. So I had lots of discussions about this stuff, and I had some really awesome experiences. For example, our very first cloud camp, there was a guy named Chris Richardson. He had just bought the domain name cloudfoundry.com. He barely written any code. And there was another guy there and his co-founder. They didn't even have a company name yet, but they wanted to do open source platform as a service too. And so that they didn't have a name, but they wanted to sponsor the event. I made them come up with a name. It was a terrible name. It was OSS 1701. And then, I mean, what kind of name was that? And then they ended up founding a company called Makara, which was eventually acquired by Red Hat, which is now OpenShift. So these were ideas in June of 2008. These were not companies, and I followed this the whole way. A fella who wanted to organize Cloud Camp in Paris got together with another guy, and those guys ended up being the founders of a company called .cloud, and then eventually they came to Silicon Valley, and they ended up starting their company here, and it didn't go so well, but they built some really awesome technology, and they basically sold off that company and started another one based on that technology called Docker. So I've got to see all this stuff where it came from and where it's going. So what I'm really here to tell you is that you know, some stuff that you probably already know, but also some ideas that perhaps you don't, and give you some demos and stuff like that, and we'll see where that goes. That's kind of how I like to do it. So in general, I like to also know who I'm talking to. So maybe you can tell me a little bit about yourselves. Like, how many of you actually work at Oracle? Really, not that many. Okay, I thought maybe since we're here, there'd be more than 5. Okay, great. Well, thanks for having us, by the way. The rest of you, how many of you are some type of, let's say, developer type? Okay, that's almost half. Okay, how about more on the sysadmin or ops, operational side of things? Okay, a couple people raising their hand twice. Okay, maybe about a quarter. How about just like management or general? Okay, yeah, not hands-on right now. Okay, the other quarter. Okay, so about half developer, quarter operations side, and then maybe a quarter neither of those, more management side or something. Okay, very good. So I'm supposed to talk about Docker, creating Docker images, that kind of thing. I'm also supposed to talk about Kubernetes, and I'm supposed to talk about deploying like Redis with Kubernetes. All right. So I'm going to talk about all of those things, and we'll see how much depending on what you guys think. So, but first, let me just introduce myself. I'm a company. I already introduced myself. My name's Dave Nielsen.
Can you make that a little larger? Because
oh, yes. Hold on. Let me do that. Yeah, I had to.
You can switch for a second so you can get your.
Yeah, sure. Yeah, I don't know if you can see that, but hopefully you can. Yeah, and you've been to my events before, so. But there you go, officially, there you go. All right, so so real quick, I should do this for my employer who pays for me to be out here and do these kind of things. So how many of you actually have used Redis at some point? Okay, about half the room. All right, very good. For those of you who haven't used it or don't know much about Redis, it is an in-memory database. Okay, that's the official way we describe it. It's very, very open source. It's a BSD license, meaning anybody can take it and really do whatever they want with it. And it is really meant for speeding things up. It's known for making things fast. Being in memory helps with that, but also the fact that it's been written really well. Basically, most of it's been written by Salvatore Sanfilippo, sorry. And he, interesting guy, he lives in Sicily, Italy. Not where you think the hotbed of database technology is, right? And he really cares a lot about the code. So when somebody contributes code, he looks through it, he refactors it, makes sure there's no duplications of functionality that's already in the code base. It's very tight, it's only about 3 megabytes when you load it up in memory. Pretty small. And he started off with some functionality to help essentially queue data as it's been ingesting to put it into a MySQL database. And it was for a telco or something like that, and all this data was coming in, and just every page view, trying to get that data in hundreds of thousands of times per second, just couldn't handle that, putting it into the SQL database. So I said, well, I'll just queue it up, because I know that if I write 1,000 at a time, MySQL could handle that. So it started off really just as like this list of things coming in, and then popping them off the other side and dumping them into MySQL. And then he just kept on adding functionality like that, a lot of in-memory functionality that help things speed up processes, or help cloud, what we call cloud native functionality, perform better. And just kept adding and adding and adding. Eventually ended up with all these different data structures, and people found it really useful, mostly as a cache. So a lot of people use Redis as a cache. So if you have a long-running query or some other workflow that takes too long, and you can just cache the results, maybe take the SQL record set result, build the HTML, store the HTML in Redis, and then it's almost just like a, it's just a static page almost at that point. But you can cache all sorts of things. And so it's very, very popular for that reason. But then it caught on, and people started using it. So for example, you may remember if you were early into like Twitter, it used to crash a lot. You used to see the fail whale. I see this whale. And the application of the database that actually helped fix Twitter was Redis. And then Redis got very popular with the Heroku crowd, those folks using Ruby on Rails, because Postgres with Ruby on Rails is actually quite slow. ORM, object relational mapping, all that kind of stuff is not very fast. So they needed a way to cache some of those long-running queries. So Redis became very popular with that crowd, and then Redis Labs took that open source database and offered it as a service for Heroku users. And it was so much in demand that the company was basically launched by that. And to date, we've had over 800,000 users. Big service. I think right now, currently we have around 50,000 simultaneous databases running in the cloud for Heroku and now other users. We've had some users start with 0, like free accounts, up to 30 megabytes free. Any one of you can go get a free account for 30 megabytes and scale that all the way up to 20 terabytes. From a free account all the way to 20 terabytes in memory. So we're very good at this. And then eventually we launched on multiple clouds, in multiple platforms and service environments, and built software to be able to manage all of this. And we took the software and we now offer that as an enterprise-grade software package. So usually when you download Redis, you get one Redis database and you run one Redis database. All right, that's it. But if you want to run many, or if you need to shard or cluster, all that kind of stuff, there's really no enterprise level product for that. Well, that's what we do. So I like to jokingly say that Redis Labs offers Redis Enterprise, which is an RDBMS, a Redis database management system. Bad joke. Okay, so, but that's what we do. We manage all of that. If you need just one Redis, just take the open source version. It's awesome. It doesn't crash. It just keeps going. And yeah, so that's the difference between. And then we ended up hiring Salvatore, who actually now works for us. So the creator of Redis actually now works for us. So now he's got some skin in the game, and but he pretty much just focuses on open source. But we're happy to have him as a part of the company. All right, so that's enough about Redis. Yeah, we're on lots of different clouds. Oh, I should mention, if it'll stay on the screen. It won't stay on that screen. Okay. Well, quick question for you guys. What do you think? Now, this is a trick question, but I'm going to ask you, what do you think is the most popular database on AWS? Let's just pick AWS, for example.
Postgres.
What's that?
MongoDB.
I couldn't hear that. Oh, MongoDB, okay. All right. Good answers. Good answers. Postgres, MongoDB. So what if I told you the answer was Redis? All right. Now, I was a little surprised by this myself when I saw this, but let me qualify this. The survey was done by Sumo Logic. Yeah, Sumo Logic, okay. And for some reason, it's like on rotate, so I won't say that, but here's the deal. If you were going to go start a database, a web application company today, would you start with your first and only database to be Redis? How many would do that? Hands up. Boy, look at all those hands. It's very few. No hands up. Okay. Right. Okay. Now here's the deal. Here's why. Because Redis is in memory. When you're first starting out, is speed with large numbers of users your primary concern? Probably not. Right. It's probably like, can I build an application that people like? User experience. All that kind of stuff. Right. That's the way it looks. All that. Speed is not your primary concern. So you might go with a SQL database, or somebody said Postgres, or maybe MongoDB, or something like that. Something that's easier to get started, right? Focuses on ease of use and ease of getting started. But what happens once that starts a hockey stick, right? You've made it. Well, it turns out that you're going to need something that scales, and you're going to pick apart the parts of your application that are slowing down, and putting a cache or using it as a primary database for that piece of functionality is probably a good idea. So Redis ends up being most people's second database, assuming they become successful. All right, so it turns out that Redis as an in-memory database, it kind of dominates that space in the cloud, at least. And so it is very, very popular once you need to move to the cloud, whereas all the SQL databases kind of compete and have to share the market. Redis is dominant there. So I don't know if I would say it's the most popular and like leave it at that. I would qualify it by saying it's pretty much in all the applications, but it might just be a couple small, very important parts of the applications. All right, so it's very fast, all this kind of stuff. My favorite part about Redis is that, anybody remember this scene from a movie? Yeah.
That's actually the sequel.
Very good, yeah. This is actually, anybody else? You didn't mention the name. 2010, okay, very good. So it looks inside the monolith and says, my God, it's full of stars. Well, Redis is full of data structures. It's really cool. And so what I mean by that is it has, most databases like Mongo, it's mostly a document store, right? Or like Postgres, it's a table with records and rows, or records and a table, right? So Redis has just a key, but then it has all these different data structures. So the key looks up something, and that something could be just a string, but it can be a hash, it can be, let's see, hash can be a list, like the original one, set, sorted set, geospatial indexes, bitmaps, lots of really cool things, and I won't bore you with that, but it turns out that when you are able to move data out of the database fast because it's just a simple key lookup, and then when you pull the data out, it's actually already in the shape that your application needs it, so you don't have to like reshape that data into that form that your application needs. You're not only having a really fast in-memory experience, but now the data is readily available for you much more quickly So the combination just is unbeatable. And you can use it for all sorts of things. We even have modules to make it very scalable. Okay, lots of customers, all that kind of stuff. All right, so let's move on. Now, I want to pose you a question. If you're going to start a new company or even an application within your department, should you start off with monolith, like one single code base, or microservices? What would you do? Monolith? What?
Can I have an app first before you ask me for design?
Can you have the app?
Before you ask me for design.
Right. Well, okay. So like use case, you mean? Okay. Use case would be a good idea. But I mean, just in general, let's just pick like you're building something. You got some customers that are going to come use it. Let's assume it's again you're starting off with a smaller number of users. So like the requirement is not a large number of users to begin with. It's unlikely that you would need to have some very comprehensive, Netflix-style microservices architecture to begin with. Okay. So, and by the way, it's really interesting. I'll probably talk about this later, but the term microservices is kind of an interesting term. If people who are really into microservices, like Chris Richardson, like I mentioned earlier, he's now writing a book on microservices patterns. He doesn't believe the term microservices makes any sense. It implies something small. Well, some microservices are massive, right? Some microservices are bigger than other people's applications, okay? Also, he doesn't believe that one microservice makes sense. I'm not sure I agree with him, but the idea if you're going all in on microservices architecture, lots of microservices, there's no such thing as one, in his opinion. Anyway, so it's a very interesting story to just dive into what a microservice is, but we'll come back to that. But typically, while microservices are very hot, it seems like everyone's got one. Like trying to explain why you need it for your first application is oftentimes just comes off. You kind of come off looking nuts because you're trying to explain why I need to break this piece off from this piece, and neither one of them are being used a lot that much, so it doesn't really make a lot of sense. But there are many benefits to microservices. So, for example, you can make it work and scale better. You can extend your application's functionality easier because you don't have to, when you want to add new functionality, you can simply focus on that, build that, and then add it in. So you can also fix things better. Anyway, there's lots of reasons why you get lots of benefits from building microservices, but let's see, where am I? Here we go. But they're typically complicated. You start off with just a monolith over there, and you just got like basically two virtual machines. You got your application code, and you got your database, typically, right? Something fairly simple, I know. As soon as you go to microservices, now you're adding a load balancer and multiple instances for each microservice. So you go very quickly from like 2 instances up to like 7, and that's just for your first microservice. So it just starts to escalate from there. And the one on the far right here, this is one of the original diagrams of their microservices map at Netflix, and that looks pretty crazy. Not only is the number of microservices can get out of hand and be very complicated, but inside of a microservice, each microservice is basically its own application. So you've got all the things you need to do for your application, you need to do for each microservice. So that's also like a lot of extra work, right? So all of this stuff needs to be thought about for each microservice. You might not do it all, but most of it you're going to end up doing. There's a guy named Kelsey Hightower. Some of you may know who he is. He writes a lot about Kubernetes, and he's now looking at functions as a service, serverless, and you got to do all this for that too. It's a lot of work. So unless you're really prepared to invest all that effort into all the different microservices and containers and et cetera, you may not want to do that. So I would recommend you start with just a monolith. You guys are probably familiar with the concept of the 12-factor app. Okay, there's a bunch of things you should do, and you get a lot of benefits out of that. Maybe not quite the same as going all in on microservices, but it's a lot less effort. But be prepared to for success. So what happens is you're going along and all of a sudden your sales or your users start to spike, well, this can start to happen really quick where the response time goes down, right? That's because parts of your application, maybe unintended consequences of choices you've made cause parts of it to dramatically slow. And so what do you do at that point? Do you throw duct tape on those pieces and just pray? Do you stop and rewrite your application and hope that you can do it quickly before your customers go away? What do you do? Well, I'm here talking about Kubernetes and containers and Redis because these two things go really well together at that point where you're starting to scale. And like I said before, this is the image that we used to see if you went to Twitter in the early days when their Ruby on Rails application using a Postgres ORM in the back was just falling apart all the time. Well, Redis, the rescue, they now are running thousands of instances of Redis to run Twitter. And it was kind of early in the Kubernetes space, but you may remember Pokemon Go, the success that had. Well, that way blew out the numbers that they thought they were going to hit when they launched that game. But they were able to scale that pretty well because they were A, on the cloud, and B, they were using very scalable architecture using Kubernetes. So anyway, two examples, and you'll sometimes look and see these kind of charts, and you think about how this works. What's going on here is that each one of these little dots around the circle is essentially a microservice or a service, and each one of those is operating its own little product independently of all the rest. Each one of these typically has at least one database and multiple versions of it too, because every time they create a new version, they can't just simply kill off the old version because look at all these other customers using the older version. So you have to manage multiple versions. So you might have multiple databases for each one of these. It gets pretty hairy. A lot of times also, these aren't necessarily all databases that are unique data. Oftentimes you might have like a product catalog or something like that. And if a lot of these have to go back and hit one database, that database is just going to get crushed. These things get very chatty, right? There's lots of talking back and forth. So caching ends up becoming really popular here. So we're having a lot of success in this microservices space. So I should be telling everyone, go microservices, right? But anyway, so yeah, there's a lot of these companies now who are scaling out, and all of these that I know of are all using, they're in the cloud, the newer ones are now using containers of some sort. Okay, so I would recommend that while your monolith is starting to scale, throw a Redis in front of it for caching. Another very popular use case for Redis is session management. Because every time you come to hit that website, you got to go check to see, is that user logged in? Well, why annoy your primary SQL database or whatever it is with that kind of activity when you can go and put the session information in Redis and relieve the load from that database to go handle other work. So there's pieces of your application you can kind of pick off and put into another database. And for session management, I definitely use Redis. So you've built something people like and are using, or you've convinced somebody to give you money to go promote your application. Neither one of those things are easy, so congratulations. You started with a monolith with some sort of SQL, and now it's time to scale. Does anybody know what this is from? You guys ever watch South Park? So the underpants gnomes. Anyway, it's a funny scene. You can go watch it on YouTube. It's kind of funny. So anyway, so yeah, scale. All right. So let's go scale. All right. So what I wanted to do, I just want to set this up by saying yes, long-running queries, sessions. Redis is really easy, by the way. It's ridiculously easy, quite frankly. Everything's a function, so you don't have to learn like a language or anything like that. You just gotta learn the functions. So if you were to build something that looked roughly like a table or rows or something like that, you'd probably use the hash example. You've got two functions. You've got h set or hm set. H set if you just want to set one field. Hm, which is multiple. You can set multiple fields. Okay, and this is basically how you create a session. Very, very simple. The one thing that people get confused on if you've never used Redis before is because the entire database is one giant set of keys, there's no such thing as table names, there's no collections of keys. It's just one giant index of keys, right? So how do you name things so that you have some semblance of organization? You basically think about it as if you're building a table with fields. This is the table name, colon, ID. Okay, so this might be like, unique ID 1, right? And that's how you put it in memory. And that's the way it just becomes a very quick lookup. Oops, did I do something? Oh, you know what? Let me plug in. So I keep doing this. It thinks I am. I left. So sorry about this. You might have to put that back on again. All right, so I'm going to just wrap up the Redis part in that it's very easy to use and it helps you scale. And then you can scale parts of your application while you're re-architecting and moving it into something that is more microservices based or what have you. All right, now, let's move into more of the Docker and the Kubernetes side of things. So I'm doing my own little project. It's like a side project that's part of what I do at my work anyway, where I'm building out some microservices that I can use for examples, where people can download and start using them themselves. And it's not, doesn't know that I've stopped and started again. Let me do this.
Just let that out of it.
Yeah. Sometimes it needs to do that. I don't like that it needs to do this, but let's just try it.
That was just a break to get more beer, I guess.
Yeah.
Nobody got up. Everybody's enjoying the talk so much they don't want to village.
I guess so. Okay, so I'm just going to keep going here while we figure this out. Remember it took a little while?
Yeah, that's right.
Oh, there it is. Yeah, okay, this is going to work. So I started thinking, like, what kind of microservices would people want to play around with? Like, if you're going to pick apart popular things to do in your applications, that's actually quite difficult. If you look around, probably the most popular thing is like a catalog. It's probably the most popular thing. It's kind of boring, but anyway, so that would be a good one. Session management. Turns out that one of the popular ones is leaderboard. So Netflix does this, and it's a very simple way of creating a custom dashboard for metrics. What you do is any kind of error message that's coming in, if you want to see like, oh my gosh, like for example, I think they do like 1 billion API calls per minute or something like that. It's like some big number, right? And so they need to know what the status is of their, not only what the status is of their APIs, but if something's failing, they need to know what it is quickly. So they built a leaderboard, and all it is, it's a leaderboard of errors. So what happens is when an error message comes in, they use the error message itself as the unique key, and then they increment the score. So when an error message is coming in a lot, all of a sudden the scores will increment quick, it'll rise up the leaderboard very fast, right? And then you can imagine how many error messages they probably get, and they can ignore certain error messages, but if the whitelist if something's on the whitelist, it might get ignored, but the rest of them, very quickly go to the top, and they use that to troubleshoot. Very quick and easy way to scale, collecting error messages, something like that.
Cascading, everybody has the same error you log on, because everybody's in with the same value.
Well, if everyone had it,
Yeah, you have a cascading error where everything got the same error hitting over and over. You're now going to lock up on that one entry. You're screwed.
yeah, possibly. It'll show up at the top, but you still got 9 others.
You're going to work a query. Well, sure.
Right. Well, that's one you probably want to focus on. But anyway, so that kind of thing is interesting. Who's online? This is another interesting one. You log into a lot of these social websites, and it shows your friends are online, right? How do they know your friends are online? Like, that's a lot to keep track of, especially if it's a big website. Like, for example, Pinterest had, when they were doing this, they had 200 million users. And you gotta track 200 million users on or offline status. So when you log in, it takes your friends, and it loads them up on a page, and it shows, it could be Skype, it could be any one of these things, right? And it shows a little, next to everyone's name, a green or a red dot, right? And all the people are online, you gotta track all that. So what they did is they took, you'll notice a pattern, by the way, a lot of these use Redis. But they took there's a not so popular function, I shouldn't say that, I don't know how popular it is, but data structure called a bitmap, or a bit array. And it's basically a key with just a whole bunch of ones and zeros. And each one of those ones and zeros is uniquely addressable. So each one could represent one of their 200 million users. It's basically a microservice with one key and 200 million ones and zeros. And you would then log in, and it would take your information, your users, each one of them with a uniquely addressable bit, throw it against that data structure, and return just the ones that were on. And then that becomes the green lights for your friends. And then you are now subscribed to a pub sub, so when any of those changes, it then pushes out the message to change that from from green to red, or vice versa. One key, 200 million bits. Pretty cool. So there's a lot of these neat things you can do. When you're uploading files or any sort of workflow, like uploading files is one. You want to know that the file actually made it to the destination, so you can track that. So anything you're tracking. That's a very popular one. And tag server. Stack Overflow built its own tag server. You don't need to build your own tag server, but basically what this is you want to know for any article or product or whatever, people apply tags to it, you want to then search those tags. So you can build a tag server. It's just a bunch of text. Sending email, that whole process, because it actually goes through multiple steps to get sent. URL shortener like Bitly, that's a big giant cache of URLs mapping to, like short URLs mapping to longer URLs. Or a scraper of popular websites that people go to, so that you don't have to actually wait for the website to load up. You can just simply show it to them. A lot of the phones now do this. Inbox monitor, you want to monitor something, keep a cache of what's going on. User notifications, you want to send a message out. Having a unique, just a one API that you call, and then depending on the on or offline status of that user on multiple devices, you then send it out to where they are. A smart cache, just kind of going back to what I was talking about earlier. My favorite one actually is a new one, it's autocomplete. Everyone wants autocomplete. Autocomplete should be more easy. Because as you're typing, you want it to recommend things like, filling out forms, that kind of stuff. So anyway, those are some that I've only started building one, so I haven't gone very far. But anyway, skip that. Okay, so we talked about microservices and Netflix. And I also want to mention, when should you be breaking up your application into a microservice? There's no hard and set rule, but there's some guidelines. So obviously, if some part of your application starts to scale, like there's this genealogy website called genie.com, and you can go to any one particular person in the entire map. They have this giant tree that you can kind of navigate. It's a whole different issue, but you can go find somebody, and then you can click on it and say, are we related? Okay, well there's a service somewhere that then takes your ID and that person's ID, and it starts traversing all of the trees. Okay, but you're not going to wait for that in your web page, right? So there's a service out there, and then eventually it emails you and says, hey, we found a match or not, right? So that would be a good one. That's a very compute-intensive thing. So when part of your application needs to scale, that's a perfect example. Or what if you want to use different programming languages? Maybe there's some component of your application just makes sense to do in a different language. You can make that off to a different microservice. Or your team starts getting too big. All right, you might just simply say, it doesn't matter what technology they use, just break up the different pieces into the functionality that those teams are good at. A lot of times this means you end up mapping to some org structure. And there's something called Conway's Law that says that when you have a large organization which designs systems, usually they're constrained to producing designs which are copies of the organization. So the organization ends up having fiefdoms, and they want to build things, and you have things built according to the org structure, which may not be a good idea. Maybe that helps somebody get a promotion, but it's not necessarily the right idea for the application. It could be, because you might have the fraud department building their own stuff, and that probably makes tons of sense, right? Big companies, you know how it is, like there's a lot of duplication going on out there, right? So may or may not be a good thing. There's something called reverse Conway's Law, where you say, you know what, screw the org structure. Let's start building the application. We're actually gonna have our teams built out according to the functionality of the application. And then what ends up happening is your company starts to mirror the functionality of your application. Okay, so, all right. Let me break out of here for a minute. Let's see. What I wanted to show you was, let's just start with the basics. Okay. Now, when I was at Intel, I was a part of a small team of people working on a project. It was basically a deep learning library that ran inside Spark. So it allowed you to do, like, if you know TensorFlow or anything like that, it allowed you to do image recognition and other deep learning capabilities, but it only ran inside of Spark. So it was sort of complicated for people to get going and try. So containers ended up making a lot of sense for us because we can provide people a container and then have to go set up Spark, set up Big Deal, and all the other dependencies, right? It's still fairly big, so having it on your laptop, it would take, if you had 16 gigs of RAM, that would work pretty well, but anything less than that, it was sort of sketchy. So we ended up saying, well, we'll put it on the cloud and make it available so folks could just SSH in and they could do their work, and there was a user interface too. If you guys are familiar with Jupyter Notebooks, okay, you could go into the Jupyter Notebook and play around with it that way. But anyway, so I was responsible for this project. At the time, I hadn't really done anything significant with containers other than just play around with it and build some toy applications. So I ended up getting pretty heavily involved in this, and it was a really cool experience. Now, what I wanted to just share with you is that we ended up building out the code and the steps for how to build this container. And we would then load the container up onto Docker Hub, and then from there we would pull it down into, in this case it was Amazon virtual machine, not a container, a virtual machine, and we'd save it. And then if somebody wanted to, they could go to this page, or they could search for deep learning or Spark with deep learning, whatever, and they'd end up at this page, and they could then launch the virtual machine. So that's how I ended up learning this stuff. So I had to make this real. Now, yes, we were running it in a virtual machine, but the reality is this could run in a container. You could download it onto your laptop and run it just in a container. But one of the benefits of this is that now that Docker container, which is essentially a complete application, you can now pull that down into any cloud. So I ended up leaving. I stayed long enough to finish this project, but my next step would have been, okay, great. Now we can go very easily and very quickly create AMIs or virtual machines on all of the clouds. Now anybody can try this on any cloud they wanted to, or just download it wherever they wanted. But it made it very simple to now distribute that functionality, even to an individual user. So here's how I did it. First of all, you'll see the instructions aren't that long, but the reality is it's a lot more complicated than this, because when you're building a Docker container, you really need a Docker file. And a Docker file, they came with their own language, but it's very similar to Bash. So you end up basically writing a bunch of Bash commands to build out the container, right? It's not Bash, but it mimics it very closely. So I'm not going to spend a lot of time on this, but I do want to show you this, so you can get a sense. And if you want to, I'll share the URLs of this stuff. So if you want to go, you can see how I did it. Let me go a little bit bigger. I guess I could use that good? That's good. Okay. So just quickly, so I don't want to I got too much to talk about. I don't have time to go into everything in too much detail. But here we're actually pulling a specific container. Okay, we're pulling the Jupyter image. So I want to pull multiple pieces into my container, right? So I'm going to pull other containers into my container. Then I have different versions of applications or frameworks that I need to install. Okay, so I specify them all here. Right? And I can even specify a specific version of the big deal. You can't even see it off the edge there. And then once I've installed them all, I'm going to go run. I'm sorry, I'm going to pull down those. Sorry. So I'm going to, of course, do my apt-get to update everything. And I need to run Maven to build. Let's see, I need to set up a file. I'm pulling down Scala. Anyway, it's a bunch of stuff, right? You're basically going through and automating all the tasks that you would normally do by hand, okay? Now, and you gotta set up some environmental variables, etc. Okay. Where am I trying to get to here? Okay, you gotta set up passwords. There's a lot of functionality, but at the end of it, you might need to run some commands to install things. Okay. And then you want to switch out of the admin user back into a regular user. Okay. So the point is that if you're going to go build a Docker file, it can be done programmatically, and you can build very complex images. But at the end of the day, you end up with this Docker file that does most of the work. Once you've built your Docker file, the rest of it is fairly straightforward. In this case, I want to build the Docker file, and all I need to do is type docker build, and it's going to use the Docker file in that directory. Okay? I could specify a Docker file if I want. I can kill the cache, so it rebuilds it even if it thinks there's a cache there. And once you've built it, you can now look for images just by typing Docker images, and you're going to see a list of your images, okay? So now what happens, you've built the Docker image by automating the tasks. You can do, by the way, you can do all those tasks manually, like I think I said before. You've built your Docker image, and now what do you do with it? Now that you've got the Docker image, what do you do with, and by the way, it doesn't have to be Docker, right? It could be, Rocket? Yeah, it could be any one of the compatible Docker's. The container runtime is now a standard. It's called runc, I think. Yeah. So now what do you do with that image? What's that? Deploy. But how do you deploy it? For those of you who haven't deployed containers before, how do you deploy a container? Do you SSH somewhere and then copy the Docker file.
You put it on Docker Hub, right? Put it on Docker Hub and
Most people are going to go put it up. Yes.
If they use a management tool. Oh.
Management tool would be nice, but even a management tool, you got to get this thing off your laptop, right? Because you don't want that Docker image to be sitting on your laptop.
Right.
Okay, what's that?
Docker Hub.
You could, yeah, if you want to run it on your laptop, you can just simply run it. That, of course, thank you.
push it to a registry.
You're going to push it to a registry, okay? So there's a bunch of them out there now, but Docker Hub's the most famous one. Even if you're not using Docker tools, you can still use Docker Hub. All right. So, let's see if I mentioned that in here. Yeah, here you go. So you're just going to do a Docker push, and then what's going on here is this is your Docker Hub name. All right. So when you log in, you get an ID. This is in this particular case, I was working with some folks named. Well, I was pushing it to. So mine would be D. Nielsen. Okay. And then this is the name of the container. And then you can version it. You don't have to put this, but like colon latest usually means, okay, I just want to overwrite anything that was there, and this will just be the latest, or you can version them. Versioning makes a lot of sense if you know that some people want to continue using the older version, okay? Or latest just lets people know this is the latest. Okay. So you do that, and then, oops, didn't want to go there, although it is nice to show you that Redis is really popular. Okay, so I'm already logged in, but you can then see, like this one is up here, right? That's from a long time ago, but once you've loaded it up there, now it's up on Docker Hub, and now you can use the management tools to say deploy, whether it's Kubernetes or wherever, or you can just log in. Oh, okay, so let's just stick with Kubernetes. You can now deploy and use Kubernetes. You can give it the YAML files with all the descriptions, and all you have to do is give it the name and or the URL to that Docker file, and it'll just pull it back down and run it. So a lot of the work is just getting to this point. You're building containers that actually will work together, all that kind of stuff, and then pushing it up here. The deployment can sometimes be very simple. Pulling it down into Kubernetes. Okay, so I want to share that with you. Now, I have another one that I was working on. Oh, yeah, and so the other way you can do it is you can simply, and what we were doing, is I was going and getting a virtual machine, just loading up a virtual machine on Amazon. I would log in, and I would just do a Docker pull. Okay, that's it. And then now I had all that functionality that I built is now in that virtual machine. And then I just had to go ahead and configure it so it automatically ran the container when the virtual machine turned on. And it would automatically set up, and when somebody would navigate it to that IP address to view that virtual machine, it would load up Jupyter notebooks. And you could then play around with Big DL. Okay? So you may or may not remember this, but if you go back a ways, there was this whole movement towards application service providers, where folks would take software that was very popular off-the-shelf software, they'd start whole companies just hosting the software for folks. And it didn't do very well, because they forgot that it's not like they're just running the software. They had to set their own data center and all this kind of stuff. So it's very expensive to start a business like this. But now with the cloud, you got somebody else do all that. And you now even have containers, which make the deployment really easy. And you really can and should take, so if you're in the software business, not software as a service, but software business, you really can and should offer AMIs or images of your software and let people try it out. And let one of the clouds do the hosting for you. So anyway, I'm just kind of curious, anybody ever tried something like this themselves, like to use containers or even just set up a machine image? A couple of you? Okay, all right. Did you use containers, or you just build your own machine image from scratch? Containers? Okay. Did you do it something similar to this, or did you do it differently? Did you use the Docker file?
Yes. Very similar to this, but
Validation, okay, very good. What's that?
Very similar to this, but not the Docker hub to our private registry.
To a private registry. A lot of, especially corporations, right? You know, that's a good idea. I think there's multiple companies now that offer registries. Docker itself, I think, offers the Docker registry as a software product. Okay, all right, so if you're gonna go build a container and offer your software to folks to try it out, this is a great way to do it. All right. Now, what else I was gonna show you is, now, let's say you wanna use, you're gonna build your monolith application, and now you wanna not just offer the software for other people to try, you wanna now take your application and run it, okay? Let's take a look at how that might work. All right, so now what I have, okay, there's lots of different ways to do this, by the way. So I have this application that I built, which is a, I purposely built something that I thought would deserve to be broken up into a microservice. All right, so what it is, it's kind of like a Twitter, kind of. But what it is you would upload some sort of image, like maybe similar maybe if you were to post an image on Twitter, okay? You've got some text and you've got an image. So the text has to go somewhere, probably a database, and the image has to go somewhere. So it's two very different pieces of functionality, right? So if you were to build this from scratch, you'd probably just throw up some code and, like I did, into the Node.js app, and you'd take the file, throw it somewhere, grab the URL, throw it in the database. Okay, not bad. But there's other things that you might want to do when you upload an image. Like for example, you might want to have multiple sizes. Okay, so the image you might need a thumbnail. Right? You might need to have the original, have one that's more appropriate for a page, and then maybe have a thumbnail. Right? That's a pretty common thing that people do with images when you're uploading a profile photo or something like that. Okay, so but in this application, it also will let you categorize the image. Nothing fancy. This is actually a very, very unfancy application. Okay, so what I thought I'd do is just walk you through what I would do to deploy something like this in Kubernetes. Now, first of all, if I'm starting off with a normal application, I'll probably set it up on my laptop. Right? That's probably how most developers would work, right? You're going to develop things on your laptop. Now, there are some situations where that doesn't work very well. You might have a development environment already pre-built for you somewhere, and you need to push your code there to try it out. But in this case, we're going to try having it on your laptop. So I'm going to send you the links to this stuff, and you can go through this if you want yourself. Now, I've already gone through, in this case, I was using Amazon S3, although I am trying to build this more open source, so I have a version I'm working on to use Minio, which is sort of a Amazon S3 compatible object store. That way I won't need to use a cloud at all. I don't want to. Okay, but that's what I'm using for my object store. So here's the instruction on how to go set that up. Now, I've got my code here, and I went and renamed on my older versions of this, so I should be able to go and do a git clone. Oops. Never mind. That is loud. Okay. Yeah, it looks like it worked. Okay, so I just downloaded the code, and I'm going to cd into upload validate. Okay, let's turn that down. See if that works. Okay. Now, in this particular case, I've already broken this into a monolith with one microservice. I told you I'd talk about this again. It's typically not common to have one microservice, but if you're taking a monolith and you're starting to break it apart, of course the first thing you're going to have is one, right? But I want to ask you, why would folks who are involved in the microservices space be so dead set against there being the idea of one microservice. Why would folks say the idea of one microservice makes no sense? Now here's a hint. Microservices are supposed to be loosely coupled. Now the question is, what does loosely coupled mean? Now in my case, in this simple application, I literally just simply took the code, pulled it apart, and I'm now making a REST API call. Is a REST API call loosely coupled?
Yes.
Could be, right? I would say yes. Some folks who are super involved in this microservices space don't think that's loosely coupled enough. News to me. I've been around this space for a long time. I didn't realize that that wasn't loosely coupled enough. Yeah?
Well, I don't know if it's about being loosely coupled as much as having the services completely non-interactive. That is optional. And that definition is better or more specific than just a REST call.
That's what they would say.
Yeah.
So how can you completely detach? Because there's some dependencies here, right? Like you gotta know the exact URL, all that kind of stuff, right? So first of all, there's this idea of service discovery. Okay, now service discovery is an interesting thing because the reason why we need service discovery is when you have large numbers of microservices. Because if you have a lot of them, and now you have, let's just, for argument's sake, say you've got 10, just 10, right? But now you got 10, you got the load balancer. You also have, different versions, right? Because you have versions of each microservice. So you could end up like with 30 of these things. Now every time you go to deploy your code, you've now got to know where 30 different things are. Or maybe even just 10, but there's 30 things that are moving around. Now, go back to some of those screenshots where you've got like 500 microservices. Can you imagine you're deploying an app and it's got to keep track of where those things are? That's impossible. But you can have like a shared CSV file that you're all updating. That's just not going to work, right? So you've got to do this dynamically. Now, there is actually a very cool project. I'm not going to recommend you do this right away, but there's a very cool project that uses Redis for everything you would need a microservice framework for. It's pretty awesome, actually. It's called Hydra, the Hydra microservice. And what happens is it uses PubSub to keep track of all the locations of all the microservices, and every client subscribes to that PubSub. And so when it needs to make a call to a microservice, it just simply looks to memory, which has been updated through the PubSub, to find out where that microservice is. Pretty cool. It does a bunch of other things too, like health checks and all this kind of stuff. Really, really cool application. But that's basically what you need to do. And if you want to learn about how service discovery and all this stuff works, I'll share that link on to the group as well on how to use Hydra. If anything, it is being used in production by Flywheel Technology. It's a Flywheel Technology. It's one of these companies that has virtual spin class. So you can be at home, maybe you're a mom or something, and you have kids, you can't leave, or me, or you work from home or whatever, you can't leave the house. They have a video of their real spin class, and you can join virtually. So you actually are having a live spin class, seeing the instructor yell at you and all that kind of stuff, but from your home. Right? It's a pretty cool business. And so they actually built this and use it for their production microservices environment.
One quick question.
Yeah.
Back to the loosely coupled.
Yeah, we're going to come back to that, but yeah, go ahead.
Okay, so, if you had just one microservice and it was just a monolithic app that was shoved into what you call now a microservice, you couldn't really scale then the components, subcomponents of that monolithic microservice. So let's just say you had an IO handler, something that was doing a lot of IO, right? You couldn't build like, a 10 or 100 or 1,000 of those things. You'd have to scale that bigger, huge chunk of blocks, across the board. So bigger Lego blocks as opposed to thin Lego blocks that are just doing that I/O handling. So that's where I would say, when you start thinking about loosely coupled, it's like decoupling the subcomponents of what that app is doing so that you can scale that wide, scale that as much as you need to go, right?
Well, I mean, if I understand you correctly, yes. I mean, there's like in the example I have here, it's simply a file being moved somewhere. There's I/O there, or it could be running to a database a lot, or whatever it is you're doing. Yeah, that piece may need to be its own layer and scaled horizontally in its own microservice. I mean, there's some situations maybe where you're doing heavy image editing or writing or something like that, where or copying, where the primary function is just simply moving files around, and then you have a simple small front end.
Yep.
Right? So that functionality of moving those files around might be what you actually consider to be the main application, but to the architecture it might look like a microservice. Right? So, but where I'm going with this is that the loosely coupled, what they might argue is that why not have messaging between the services be more of a pub/sub type of messaging, where when you want to communicate to the other services, you simply publish to the services that have subscribed. There could be 0 services subscribing. There doesn't have to be anything anywhere, and it still works. Like, there's no error message, right? So it says, hey, this thing's updated. And if there could be thousands of things, or there could be one thing that's listening, and it scales. So that's one way in which they would argue it doesn't make sense to have one microservice, because what are you publishing to? All right? It doesn't really make sense. So the pub/sub concept can be very, very effective in a microservices environment. You let them come in and subscribe, and then you just publish it out, and the message gets delivered.
Well, in that model too, if you have some sort of stuck thread or something on that one bit, now the other ones can take over and deal with that as opposed to being
That's right.
app locked.
That's right. There's a lot of advantages to this model. It does take some sophistication. You're building out some additional components that you don't want to necessarily bother with when you're first starting. But yes, it scales extremely well, and it's not a REST API call, right? It's different. You're sending a message out to those that have subscribed to you. All right. So yeah, and then service discovery. How does that work? Well, at the end of the day, what you could do is simply take the manual way of doing this is when you've published an API, you then take the location of that API and you load it up into an environmental variable on all of the clients. That's the manual way. And then with service discovery, what happens is you have, it could be pub/sub, it could be whatever, but you have a way of having a service that knows where all the microservices are and receives their address, and then again will probably push, depends on how you want to deliver it, but need to push that data down into the clients, again in an environmental variable or something like that. There's a new way of doing this now within Kubernetes. There's a project called Istio. Have you guys heard of this? Okay. So Istio has a bunch of capabilities. It's definitely not one thing, but and that makes it hard to describe sometimes. And I'm no expert in it, by the way. But I believe the way part of it works is when you have a pod, which is a bunch of components that need to be near each other, you can have this concept of a sidecar, which basically is something off to the side that's not really part of your application, but it's providing some services to that pod. Sort of like a sentry or something for that pod. And what happens is that sidecar will have the information on where the microservices are in it. So you just need to tell that sidecar and all the different pods, and the messages always go through the sidecar, and as they're going through, they look up to see where that microservice is. So the application code itself never cares. Right? And that's a nice way to do it too. So these are some different ways to handle service discovery, and in my opinion, this concept of service discovery is the main component that's different in sort of a microservices or a Kubernetes environment, because you're now turning over the location of the things you're talking to something else. And basically, it's slightly different depending on what mode you're using, but it's basically service name, function name. That's what you're going to call. And you're going to send that out, and somewhere it's going to get translated into a location. Kind of cool. Okay. And then the second thing is, if you want to take it that far, is the concept of going even more loosely coupled, which is now don't make REST calls. You can now publish messages to those who have subscribed to you. Okay. So those are, to me, the two big concepts that probably a lot of the big boys are using, but you don't necessarily need to do when you're first getting started. Okay. All right. So I think I'm going a little longer than I intended to here. So let me move along here. So in this case, what's happening is I've downloaded the code from my GitHub repository, and I'm going to go into my API. So this is the API I created, and I'm doing this manually because that way you can see what's happening. So what here I'm doing is I'm going to copy the environmental variable file, and now oops. There you go. I don't know if you can see that, but basically it's just a config variable file that my application is going to read to find out where things are, right? And this is the thing you need to automate, because in a microservices environment, that's going to be a nightmare. All right, now in my application, I've got these values. Well, actually, here, let's just do it one at a time. So we're going to tell the port to be, I don't know if I'm going to do this all right, so we'll just, hopefully I'll do it right. Okay, localhost, okay. Redis is always port, well, default is 6379. I don't have I didn't set up a password, just leave it. I think it's actually going to tell me something funny about that, but okay. And then I did, okay, that's not quite right. I think I missed something, but I didn't. So this is just the keys for storing. So this service, this is the API that actually takes the files and loads them into the object store. Okay. And
You missed the one at the end.
no, I didn't.
Oh, you did?
No.
Oh.
I purposely put the one there. This is like public stuff. So okay, so those are just the configurations. All right, now let's see here. I think I already did all this. Okay. So okay, that's the configuration for the API. Now, because this is Node, I'm going to, let's see, did I do everything right? I think I did it right. I may have not, but we'll just, the next thing I'm going to do is I'm going to now install this and start it. So npm install. So let's make sure it's got all the packages for all the dependencies that Node.js requires. Took me a while to figure this out, but npm, that's the main functionality. And what's funny about npm, by the way, if you've ever used Node, is that, do you know what npm start does? Anybody know?
Search project.
Well, yeah, but it does other things too, apparently. Because normally you just say, like, you know, node start, or, you know, whatever, node the server, or the file, right? Which is basically all this does. But it also tells it to go look in the project, or whatever, the package.json. That's what this really does. And it's just starting it, but it's going and looking in the packages. Package.json, I think, or project.json, one of those two. Which one is it? Package, okay, yeah. All right, so let's start that. Okay, so now my API is running, I think. Oop, wait, what happened? Oh yeah, okay, so I think it's working. It's just that I should have just deleted the parameter for the password. Okay, so that should be running. Oh, earlier, by the way, I ran Redis, okay? And running Redis is super easy. It's just Redis-server, okay? You can ignore the error message, but that was something else. So Redis is running. And now I'm going to cd website, okay. So, oh, I know what I did wrong, hold on. That should have worked. Yeah, okay. Let's see, I need 8080 and 3000. I've already got that. Localhost is fine. Okay. All right. So, and we're doing the same thing. Okay. All right, installing the dependencies. Yeah, looks like it worked, and then npm start. Okay, so that seems to be working. Now, yeah, so it should be working at 8080. Let's go see what happens. We'll host 8080. Uh-oh. Okay, I think I'm in trouble here, honestly. Because this looks like an older version. Hold on a second. Let me do something else here. Let me, somehow I'm screwed up. Let me try something else. Sometimes the ports get whacked out. So, let me do this. I think I screwed myself up somehow. Let's try this again. Go to 8081. There we go, okay. All right, so I somehow have some sort of port conflict, and something right now is taking over my 8080, because that was an older version of my app. And it's, I'll have to chase that down and figure out what's going on. Okay, so this is a very simple app. All you do is you choose a file. Let's, probably should have actually done something a little more clever here. Let's see. I don't even know what I'm looking at here. That could be dangerous. All right, so let's go, and I'm going to give it a category. So category 4 and submit. Oh, okay, I know what happened. Hold on a second. That just means I forgot to create there's a dependency somewhere. So I'm working on this with someone else. I think they overwrote my my changes. Hold on, that was, I know what that is though. That is images uploads under public. So, let's see, that's going to be, what was it again? Images what? Uploads. Uploads. Okay. I think it's just this. I go back and forth between MD. I go back and forth between Windows, and I've forgotten all of a sudden.
Oh, MKDR.
Yeah, that's right. Thanks. Sorry, just images. That's right. Okay. Images uploads. Uploads. Boy, I'm just brain. All right, let's see if that worked. Now, shouldn't have had to have changed anything. Let's just see if that does the job. Nope. Might be cache or something. Shoot. Well, I probably can fix
It's all in
this.
a public directory, right?
What's that?
You have your images directory in a public directory? It's looking for public images, I think. In the error.
Did I do it backwards? on a second. Okay, right now I'm in. Oh, it says file exists both times, right? That's already there.
You are in public.
Okay, so I don't know what happened here, but I think I just screwed myself up somehow. What should be happening is once I upload that file, it should show up here as an image I can validate, and then what would happen is I would specify, yes, that is the right category, or it's the wrong category. The purpose of the application I'm trying to build is if you have an event and people are submitting images like through Twitter or something like that, and you want them to appear on your event website, you probably want to validate them before they appear on your website, right? So that's what I'm building here. But I somehow screwed up because, oh, you know what it might be? Let me try one more thing. And this right now is an API. I don't think it matters, but let me try. Okay, and then, so I needed to make your images. Let's see if that works. No, shoot, I screwed something up. It should be grabbing it right up there, and looks like I created it. Shoot, okay, well, this is what happens when you collaborate and then don't test your app before you do your demo. Okay, so anyway, but you get the idea. And then once you're done, the images that are validated will show up here. All right, now, we've developed this, deployed it, tested it on your laptop, and now you want to go deploy this into Kubernetes, right? Because you've got your application and you've got your service. You should be able to deploy, right? Now, one of the cool things you can do is install Docker on your laptop. Has anybody just deployed Docker desktop on your laptop? Has anybody done that? Okay. Have you noticed anything new lately?
Yeah, it uses the CPU all the time.
Yeah, it does that, huh? Did you notice anything new?
I've not noticed that. That's cool.
All you do is update to one of the later versions, go over here, check that box, and you will have Kubernetes running on your laptop. It's that easy. I wish I could say, oh, I was slaves and I really got Kubernetes to run on my laptop. Well, I mean, you could go with Minikube, which is not terribly hard, but it's definitely not this easy. Don't worry about this. This is for the default orchestrator. It has nothing to do with like if you're just using plain old Kubernetes. So just check that box, and you'll see it over here. It'll start saying Kubernetes is starting, and then it'll say Kubernetes is running, and now you have Kubernetes. Okay, now it's kind of cool. Let's go back over to my repo. Okay. Now, if you liked using Docker with Docker Swarm before, and that's the way you're used to doing things, you can still use Docker Swarm. Okay, it's not as popular as it used to be. But with Docker Swarm, you'd use a compose file. Okay, that's how you would set up all your YAML details. And you can still do that, and there's another project called Compose with a K, so Kubernetes Compose, that will translate your Compose files into Kubernetes files. So that's pretty cool. All right, so if that's how you've done things in the past, you can still use Compose with Docker, develop on your laptop, even push into Swarm on your laptop if you want. But now you don't need to do that, you have Kubernetes on your laptop. And so what I did is I went through the steps, and if you want to, wait, hold on, which one is this? Man, things have changed again. Okay, well, it's close enough. All right, so I know it's an older version because it says Docker Edge now. That should not say Docker Edge. This is interesting. Docker Edge is like the Docker desktop version that they release early with things that they're not sure they're actually going to put into the final version. So that's like the cutting. It's like Fedora for Red Hat. Okay, so anyway, let's see if this works. So we're going to go through all this. Okay. All right, now, what I would do, because I'm probably going to get stuck on this thing, because it looks like there's some changes here, I'll go through it, and if it gets stuck and it breaks, it breaks. Okay, but what you're going to do is, remember this from before? Okay, Docker build, all right? So I can go in here and I can say, you know what, I'm gonna kill myself if I do this, all right? Let me just not waste everyone's time. I'm gonna just explain what I'm gonna do. I'm gonna, just like before, when I had gone through and built my container before, I can now use docker build /t, and then again, remember this is my Docker Hub account, and that's gonna be my repo name, like the container repo, not GitHub repo. Oh. I haven't plugged in. Really? I'm plugged in, seriously. So.
He knows the video later.
Okay. Well, I'll just keep explaining while we're going through this, and you'll understand. So what happens? You go through. I'm going to go through and build a container for my application and for my API. Okay. I'm then going to push each one of them up into Docker Hub. Right? Now that it's there, I need to make sure that I update the YAML files in, again, if you're using with Compose, put your details in Compose, or you can instead put them just right in the Kubernetes YAML files. Yeah. I don't know why I did that. Unless this doesn't have power. No, it's charging.
First time I'm using the system myself. Yeah.
All right, so I'm just going to keep walking through. And then with Docker Desktop, you target your desktop. For you log into Kubernetes, kube control is the Kubernetes client. You target your desktop, and then when you go and do your kube control create for each one of your YAML files, it'll tell Kubernetes on your desktop to create those services. Okay? And then it takes over your port 8080, I'm pretty sure, because that's an old version that we just saw running inside Docker. And then you just navigate to localhost :8080, and okay. The future is here. It's just not evenly distributed. Okay. So yeah. So you need to go obviously update your YAML files. But once you've gone through and updated your YAML files, in this case I had to update my S3 even though I'm deploying onto my laptop, it's still pushing the images to Amazon S3 because I don't have a local object store compatible. Okay, and this is where you go through after you updated your YAML files. Now I have a YAML file specifically for my API service. Okay, for my website. It's got the configuration details for each one of those. Now I've got to have a load balancer. I don't know what's going on, dude. I don't know what's. I'm not touching anything, am I?
Is it that the bulbs have gotten hot? I don't know.
I don't know. That one's doing it too. Okay. So at this point, we're kind of into all the weeds of Kubernetes, but every service has to have a YAML file, or at least has to have. You can do it maybe one large YAML file, but you've got to have all your deployments, your services, all that configured. And you go through and simply use kube control to create each one of them. And once you do the last one, it's running. Okay, now you've deployed it into your laptop. Now I've tested this out multiple times, obviously not today, but multiple times. And these same commands that I run on my laptop, I can then go and target different Kubernetes cloud, and it will work. As long as it's the same, or relatively same version of Kubernetes. All right? They're about 0.3 versions off. The one here, I think, is like 1.6 or something like that. And the Google one was the latest, and it still worked. So, yeah. But, okay, now that you've deployed on your laptop, you can simply retarget to the Google or whatever cloud you want to use that's running a Kubernetes service. It should work. All right, should. There are some dependencies, things like your object store that it's kind of funny because I'm deploying on my laptop, I'm pushing my images to Amazon S3, I'm deploying the Google Cloud or Kubernetes engine, and it's still putting the images over on S3. So obviously your backing services still need to be converted to whatever cloud you're running on.
You have another 1 minute.
I don't know what I did. Somebody back there with like a clicker or something.
I don't think
just
you're
messing
doing
with me?
anything. I'm guessing it's just the bulb maybe it's heating
I
up.
don't know. And maybe it's getting too hot.
Maybe, that's my guess.
I'm full of hot air, so. Okay. So I kind of got off track when I started messing up my deployment here, but I want to pull it all back together here. So right now, when you deploy using Kubernetes, you go through and use the Kubernetes commands. And I really recommend that you do this to understand what's going on under the weeds, or in the weeds, under the hood, metaphor. You start seeing that there's just a lot of detail here, all right? There's a lot of these, you gotta tell the pod information. You gotta tell the service. You've got a deployment. Okay, there's, oh wow. Yeah. So you got a deployment that you've got to configure, and they all have. It's like the movie Inception. There's like all these different layers inside of layers inside of layers, and but eventually you get it, and then you start to understand architecturally where you need to scale. All right, because I'll give you a couple of hints here. If you're deploying a database and you have just Redis ephemeral, which is just in memory, you're not storing anything on disk anywhere, you probably don't care too much about where that data is being stored. And you don't have a secondary instance. So that's pretty easy. There's nothing really else to worry about, just where that runs, and you can use it as a cache. But if you're using Redis as a primary database, well, first of all, you probably want to have a secondary, because that way if the first goes down, you can fail over quickly the second. And then, of course, you want the second to be storing the data on persisting it somewhere. So if the second goes down, you at least can recover. You'll have some downtime, but you'll be able to recover quickly from the persisted data. So now you got to have your primary and your secondary. Do you want your primary to be in the same pod as your secondary? Maybe not, right? Because if the pod goes down, because a pod might be one physical machine, all right? So you probably don't want them in the same pod. So it's good to understand the layers of inception within Kubernetes so that you know, oh, okay, well, I'm going to have my secondary instance for Redis in a second pod. Okay, and then you also have to specify your storage, of course, and that's just another parameter inside of the Kubernetes YAML file. But there's lots of detail there, depending on what you're using for your storage. With Redis, you can actually use Redis without having any EBS anywhere. Persistent. Where is it storing? In an object store. It's slower though, because writing to an object store is actually slower than writing to an EBS, even if the EBS is detached, across the network somewhere. But all of these things, you need to understand where they are so that you can configure your deployment appropriately. Now that said, I've gone through all this trying to explain in the best way I can right now how Kubernetes essentially works with containers and how you might start with a monolith and go to microservices architecture. However, are you likely to use Kubernetes by itself? Ask yourself that, man. Are you going to deploy an application directly on top of Kubernetes? Maybe, but maybe not. Because there's all these platforms now that are building on top of Kubernetes. Okay, so like for example, I mentioned Cloud Foundry. Cloud Foundry is now adding Kubernetes support. Why? Because Cloud Foundry views itself as an entire cloud. So if it's an entire cloud and you have your CF push to push your code into the traditional Cloud Foundry, but you've got all these backend services, you've got users, you've got teams, you've got all this stuff. Why not also have Kubernetes where you can push containers instead of code? Just got two choices, right? So Cloud Foundry is now supporting Kubernetes. Oracle is supporting Kubernetes. Amazon, Google, Microsoft, IBM, DigitalOcean, Alibaba, the list goes on. Red Hat is supporting Kubernetes, of course, within its OpenShift. And Red Hat OpenShift was a mess for years because they kept changing things over and over, rewriting the whole darn thing. I mean, it was like, I was running the OpenShift group like 8 years ago and I quit. I was like, this is just crazy. So they finally, like a couple years ago, standardized on Kubernetes or Docker and then Kubernetes, and now things are starting to finally gel. So you might use OpenShift, all right? If you use OpenShift or you use Cloud Foundry or maybe some of the other ones that are now building up around Kubernetes, fundamentally they have Kubernetes underneath. But you actually don't touch it. It's kind of like Linux, using Ubuntu and the GUI and all that kind of stuff. That's not Linux. That's what they put on top of it, right? So anyway, my point simply is that while I think it's important for us technologists to understand this stuff right now, I don't know where this is going to go. It may turn out in a couple of years that you don't care about this anymore. You might care about it from a performance perspective. So if you are caring about performance, that's going to matter. But as a developer, you might not. As a developer, it might be that just like I'm recommending you just build a monolith now, it might be, you know what, just push it into one of these platforms as a service to begin with, because you got everything all kind of nice in there. You don't have to worry about configuring all these little details. Get it up in the platform, test it with your users, make sure it works, and then move it over to maybe like a bare bones Kubernetes or something like that where you can like really get the performance that you need or the scalability or the tweaks and all that kind of stuff. So, and then those platforms completely take care of service discovery. They have built-in client libraries and all this kind of stuff to handle loosely coupled and all that kind of stuff. So they kind of take care of all this stuff for you. My only fear with those kind of platforms is they in fact, the Cloud Foundry folks will even tell you they're very opinionated. So like you're going to live within the world that they have built for you. It's Microsoft all over again. Some people love that. If you're a Visual Basic programmer, you've never programmed, this is how I was when I first got started. Never programmed in my life, learned Visual Basic in about 6 weeks and was building applications for customers. Yes, that was awesome. And that took me off on a whole path that I never had expected, right? So for some people that's great. For others, that's just a bunch of extra nonsense that's not necessary. So, I don't know. What do you guys think? What do you guys think about the options that are out there? For those of you who, especially for those of you who've already started doing containers, are you going to stick with like bare bones Kubernetes, or are you going to try to use some other framework on top of that?
Top of your laptop says something at home. That's really useful.
Yes. Okay. Thank you. All right. Let's just quickly iterate on, and then let's compare, and then we'll call it a night. Okay. What do you think? Does that sound reasonable?
Just as a FYI, tomorrow there's an all-day online session on Istio.
Oh, that's right. Thank you for reminding me. That would be really cool. If you're interested in Istio, you can go follow that. It's like the version 1.0 is just the first time they're doing the training on that. Yeah. Very cool. But yeah, so Helm. Anybody else?
Rancher is what we are also looking at. Rancher is what we are looking at.
Rancher?
Multiple
Yep.
instances, like clusters of Kubernetes.
Yep, Rancher is sort of a multi-cloud,
Right.
multi-cluster deployment framework. It was sort of a competitor to Docker. And
Right, they had
those
their
guys.
cattle, they used to call it.
What's that?
Cattle.
Cattle, yeah. So, but they've taken the approach of being multi-cloud deployment framework and system, yeah. By the way, and that they seem to be doing pretty good at that, or pretty well at that, actually, yeah. Okay, so Rancher. I already mentioned Cloud Foundry folks, and which like Pivotal, and then the Red Hat folks with OpenShift. What else? And Helm is kind of below that. It's in between sort of Kubernetes and the higher frameworks. What else is out there?
Mentioned this to you a bunch of times. There's Apogee.
Apogee. I'm glad you brought them up. I haven't really followed up on them lately, but those guys have always been innovative. Apogee's was it? I gotta go check on them again, but I remember those guys. Yeah, they did something really clever. They would actually rewrite your code without you knowing it in the beginning, but it was awesome. Because people don't know this, but that's what Heroku did too. Because they had things that they would do to make it work better with the databases than what normally all the frameworks would do. So they would actually rewrite like your database connections and stuff like that. Because otherwise, I don't think anything would have ever worked.
Their newest version actually stacks on top of Istio. So you get Kubernetes and Istio, and you get Apogee in there. They've got a plug-in to the sidecar.
Oh, really?
So Apogee is now sending commands out to all the sidecars instead of sending everything from one spot.
Oh, that's awesome.
Yeah, one less point of failure. I love that.
Yeah, I'll have to definitely check that out. Those guys have always been innovating. Okay, what else? There's other stuff. What else you got? All right, so let's talk about Helm, because Helm is actually really popular. So first of all, what is Helm?
Well, if you look at Kubernetes YAML files, they're really awkward and have a lot of repetition, and they're mostly boilerplate stuff. So what Helm is doing is saying, look, your application has about 5 things that are worth varying. Let's extract that, so you just put in the things that are actually different for your app. Then you publish a Helm chart that has all the rest of the assembly in place to, say this, your Redis always connects to your app server. You don't need to expose that. You just connect them up.
Yeah, some people are calling it like, you saw NPM was a package manager. Some people are calling Helm like a package manager for Kubernetes. To me, that's not quite right, but it's in the category, right? Because inside of Helm is like a lot of instructional stuff that makes the installation more complete, I would say. Because if you're just looking at a YAML file, there's not a lot of flexibility there, right? Helm has a little bit more flexibility, like you're saying. You can templatize things. I think, and I'll have to go double check on this again, but I think you can actually tell it to run some code like at the beginning or the end or something like that. So there's some way to actually run some code or something like that. But even Helm has some limitations. But I want to tell you this, that from the perspective of deploying stateless code, like you deploy your application, the code part, Helm seems to work great. All right, so, and this is basically how Cloud Foundry was too. Like Cloud Foundry was great for deploying your code, not so great for deploying stateful things. And Helm seems to be really good at deploying stateless things, not so great at deploying stateful things. Okay, so right now there's a lot of talk about something called operators. So CoreOS came out with this thing called operators. And operators, and I'm not going to give a very good description of this. In Kubernetes, there's a custom resource. It's a CRD, custom resource descriptor or something like that. Anyway, with an operator, it's basically an application. It's like a completely separate application. Now, why would you want a completely separate application where you're deploying a database? The reason is that when you deploy a database, there's a lot that goes on there. You've got to coordinate between primary and secondary storage. You've got to coordinate activities. What happens when a failure occurs? Do you just simply replace? No, because now you've got to do some sort of syncing to get the data back to where it needs to go. Okay, because when you bring up the new VM or the new container, there's no data in it, right? So you got to start doing stuff. So there's a lot of activities that happen around stateful things. to manage that state and to move the state around. And Helm doesn't cut it. We've tried with Redis. It basically wants to it keeps wanting to replace over your state. So you basically are saying, oh, I got my application going, data's going in, oh, something happened, replace. Well, where'd my data go? Okay, so there's a lot of problems with state when it comes to cloud. Cloud doesn't like state. And so you gotta have code to basically manage that. So operators are essentially an application that you create. You shouldn't have to create it, but like companies like Redis should have to create an operator that basically runs as a separate application, and when something goes south with the database, it is able to correct things. Okay. In Redis, we already have something like this called Sentinel, and in Redis Enterprise, we already have our own version of this, and so it's a little bit tricky. Now, what do we do? Sounds like we have to actually create a third thing to work within the way the Kubernetes ecosystem wants us to work. But anyway, so long story short is Helm, definitely popular. It looks like operators are going to be like effectively like the Helm, but for stateful things like databases and other complex things that have state.
They're also going to have those different functions of service.
Well, yeah,
You can tell me that now if you want to change your subject.
that's a whole other topic. Okay, we can't get into that because that's going to be a whole other can of worms. But yeah, so yeah, we should start wrapping this up. But so within the Kubernetes ecosystem, I would just leave it at this: Docker, desktop, or Minikube on your laptop, both the best ways I can think of for running Kubernetes on your laptop and developing. Deploying, you can just do it straight with Docker, with the Kubernetes YAML files, or like I was showing, you can use Compose and have them translated using Compose VK. Deploying, you can deploy onto bare bones Kubernetes on all of these different clouds. I love this, by the way, that the kube control is now becoming like the one API to rule them all. It's pretty awesome. And then, of course, you've got the platform as a service vendors who are building up. And if you take a look at what's happening on the different clouds, of course, Amazon, we all know, is in the lead overall. It's actually kind of in the lead on Kubernetes too, just because it's already so popular and they have a Kubernetes offering. So because they've got a large audience, they're already, the leader with Kubernetes, but by no means anywhere near the same market share they have on the rest of the cloud. So, Google has stolen away a little bit of that, and I think even Microsoft and some of the other clouds that are offering Kubernetes are going to gain a little bit of market share because they basically have a very equivalent offering, at least on the stateless side, right? It's the stateful side that's going to help Amazon stay ahead for a while. And then finally, my sort of like last closing thought on this is that the question then remains, or I guess could be asked, does that mean that Kubernetes is it? Is Kubernetes the Linux of the cloud? What do you think? Is it too early to tell? Is it no way, something else? Or what do you think? ...
For now.
For now.
Yeah, to be
What-
continued.
You have to note that Kubernetes is being managed by the Linux Foundation.
Right,
So it's
right.
got potential.
It is being managed by the Linux Foundation, so
Yeah.
they'll certainly promote it that way. That's a good point.
Cloud native computing, whatever organization that was managing it. The
Yeah.
Linux Foundation does the open container. Are they the same thing?
I think the Linux Foundation manages the Cloud Native Foundation.
Yeah.
I think that's how it works.
Okay.
Think, right?
I thought Kubernetes was the cloud native computing.
Yeah.
It is, but it's managed by so the Linux Foundation has basically become an umbrella.
Right.
I did not know that.
Yeah.
Cool.
Yeah, it manages the Cloud Foundry Foundation too. Yeah, it's pretty interesting. Okay, so in my opinion, the reason why I think we can say game over and Kubernetes is won that layer, the reason why is because all of the clouds have now adopted it. And once you have all of them running it as a service, well, like they're all doing it fairly well, there's just simply no reason for anything else to come in and take over that spot. Why would anybody invest that much to replace something that is now essentially free when it's done well? I wouldn't say it's the best, but it's well, right? It's good enough, right? Linux is the same way. It's not the best, but it's good enough, right? So I just don't see how, once something establishes itself in the cloud like that, I don't see how anybody else would ever muster up enough resources. What would be the motivation? You see what I'm saying?
There's always motivation for that. I mean, there was a day when just, having a megabyte on for storage was, I can't imagine writing more than that. Now, look what we're writing, It's
No, that's a very true point. But I think it's very similar like with the phones, right? We've got the Apple, we've got the Android. Amazon is essentially the Apple. Kubernetes essentially is the Android. Sure, another phone could break in, but it's gonna be tough, right? It'd be really tough.
Yeah, Motorola said that, and Nokia said that, It's just...
Yeah, exactly, that's true. All these things, I mean, the wild card here, which was mentioned earlier, is functions as a service or serverless or whatever you want to call it. That's the wild card, because that's clearly gonna have a big impact, but we just don't know how much yet.
So what you're saying is really makes sense to me, because what we are seeing in Oracle right now is once we had the Kubernetes service out on the cloud, every other Oracle Cloud service is being deployed on top of Kubernetes, as against where it was running before, which is on VMs. So now it's all being Dockerized and it's all being put in Kubernetes. So that's becoming the base platform on which everything is deployed. Even the function service is going to be running on Kubernetes.
Yeah, and I mean, I'm definitely biased, but like my experience at PayPal tells me that once you put something up in a cloud and it becomes popular, it's like you have one place to fix something and everyone else gets the benefit. And you can fix it quick. So once that catches on, it's super difficult to displace it. And the fact that there's multiple of them, to me, is even more powerful, because it's not like they can say, oh, well, we're now the dominant powerhouse like PayPal kind of is, and we can just kind of ride out our popularity because everyone has to use us. No, you've got multiple of these folks running it as a service, competing, driving innovation. I mean, I just can't imagine it in the next 10 years at least. And 10 years is a lifetime, so I just don't see anything displacing it. So my bet is on Kubernetes, but the wild card is the serverless stuff, the function as a service stuff. So what happens there? And then Kubernetes folks have come out with a function as a service, but I mean, it's going to be a tall order to go beat the other clouds that are offering, serverless. That's going to be a really tough battle. So,
yeah, I think I agree with you in that Kubernetes obviously seems to have market share and everything like that, but as an innocent bystander, for want of a better phrase, technology. I seem to feel that technology, every time we create something, we just start adding more weight to it, and then Kubernetes, Docker, lightweight, super simple. Oh, now you need Kubernetes. Now you need a Kubernetes package manager. Now you need a ... and the weight turns it, and then all of a sudden somebody goes, oh, I don't need all that, and then before you know it, some bright spark in someone says, I've just invented this super lightweight thing. It's called a monolithic application. I'm not saying we're going to go back there, but I sometimes feel that just the weight of everything that comes with it, all of a sudden people start regressing or coming up with ideas, and so I don't think we'll shift Kubernetes, but I think we might see rebel things, because as you say, just because of the sheer size of the infrastructure that comes with it now, it's not just that simple little Docker deploy. It's all this as well.
I kind of see it as dropping into the woodwork. I mean, you talk about Linux dropping into the woodwork, and Docker's dropping into the woodwork, and I think it just drops into the woodwork. So it looks huge to us now because like a megabyte used to look huge to us now. go forward 10 years ago, all this junk that we do with Kubernetes and even Istio, it's in the woodwork, so it doesn't look heavy anymore because your phone can do it easily.
Well, I agree, but the fact is, just like Cloud Foundry, they're trying to hide all of it from you because that means that the companies are already saying, no, it's already starting to look complicated, involved, investing, and we're trying to abstract it away from you so you don't have to worry about it.
Yeah.
And that's where I think you get some of that kind of rebel spirit. Okay then, how do you really abstract it away? Do you need all that weight?
Yeah, we might like the Go programming language, right? Like
Right.
it's doing a nice job of that, where it's just compiled for the OS. No longer there's no longer like a virtual machine.
Right.
Yeah.
Just gives add that, when it disappears into the woodwork, it becomes a serverless infrastructure for the user. But for the admins, it's Kubernetes all over again.
Yeah, I've definitely seen Kubernetes on top of Kubernetes. That is out there. There's multiple of those actually. It's kind of funny. I've seen people deploy OpenStack with Kubernetes. I've seen people deploy Kubernetes with OpenStack. It's really funny. So I was gonna wrap it up with something. Well, yeah, I'm guessing I think Kubernetes is going to be the Linux of the cloud. I think I said that already. But I think what's fundamentally the challenge now is the backing services, the data. Because yes, you can deploy an application on Kubernetes across any one of these. But as you saw, look how I wrote the code to run on one cloud, and I only had one backing service. It was serverless, which was the S3. And I moved my code to somewhere else, and it's still saving the files over there.
It's taking a hard look at what Portworx is doing.
I really like what Portworx does, but still I don't know if I don't know how much.
There's a long way to go with that world.
Yeah.
They're attacking it anyway.
I don't know how multi-cloud they're going to be. Yes, they'll run on multiple clouds, but will they be really moving your
Yeah,
files?
they'll be compatible, but the speed of light isn't going to change.
Yeah. Portworx, by the way, is basically an elastic block store component that runs in a container, so you can save to a file system within your container.
Multi-cloud for your storage layer.
Yeah, there's Storage OS. There's also a company called an open source startup called OpenEPS. So there's some interesting things going on there. But that's it. That's all I got for you. So. I'm gonna work on my demo now.
Thanks a lot, Dave.
Yeah, you bet. Thank you very much.
Thank you. Sorry for the trouble with the projector. And thanks everybody for coming, taking time from your busy lives and away from family. We will try to have this every month. Please post on the East Bay Cloud Native the topics that you are interested in listening on. And I will do my best to find speakers on those topics. And if you would like to share something that you are doing in your company or your project or demo that you have, POC working, or something that you've learned at your place, please shoot a message on the East Bay Cloud Native Meetup, and we can schedule you as a speaker over here. I'm planning to do this every third Thursday of the month, so keep that blocked, and hopefully we will continue this every month.
Great. Thank you.
Thank you. You guys are welcome to stay back a little longer if you want to and have some more beer and network. This room is available to us for another 1 hour if you want to.
We get the same plate this time. I'll take my phone to do a roll.
Yeah, the Red Workshop. Yeah. No, I was at the one in Palo Alto today. I didn't start that workshop, but I started like one of the very first presentations 2 years ago. Well, that's all we had. Now they've got this full. It's pretty cool. Yeah, you're very welcome, Andrew. Oh, hi.
CO2. Yeah. I'm trying to see which, like, I want to book this conference room for specific days.
Okay. Yeah. Yeah.
Thursday.
Have the list of all.
Thursday.